Good morning. In this session, we are going to see a topic on laminar flow. Laminar flow is nothing but the flow of fluid in highly ordered motion and smoothly is called laminar flow. The flow of high viscosity fluid such as oil at low velocities is typically laminar flow. The classes of convective flows. It is extremely divisive and the several parameters involved that are fluid properties, geometric, nature of flow, phases, etc. Systematic approach is required. Classify flows in a certain types based on the certain parameters. The classifications are based on geometry, driving mechanism, and number of phases and nature of flows. The geometries are external flow and internal flow. And the driving mechanism, there is a natural convection, forced convection, or mixed convection. Number of phases are two types. They are single phase, multi-phase, and the natural flow is laminar and turbulent. How to solve a convection problem? Solving governing equation along with boundary conditions with a conservation of mass and conservation of momentum and conservation of energy. In conduction problems, we need to solve these three conditions. In convection, all the governing equations need to be solved. In convection, we need to find out the three numbers. That is, one is a Nusselt number, Prandtl number, or Reynolds number. The formula for Nusselt number is N is equal to Hx by K. That is a convection heat transfer strength by conduction heat transfer strength. For a Prandtl number, momentum diffusivity by thermal diffusivity. And for a Reynolds number, Ux by V, that is inertia force by viscous force. It's a diagram for laminar and turbulent flow. An internal flow is surrounded by a solid boundaries that can resist the development of its boundary layer. For example, if there is a pipeline, an external flow on the other end or flows over a bodies immersed in an unbounded fluid so that the flow boundary layer can grow freely in one direction. The fluid particle adjacent to the solid surface is at rest condition. These particles act to retard the motion of adjacent layers. The momentum balance, that are the inertia forces, pressure gradient, viscous forces, and body forces act on it. The energy balances are convective flux, diffusive flux, heat generation, energy storage, etc. Hydrodynamic boundary layer. One of the most important concepts in understanding the external flows is the boundary layer development. In these conditions, we need to study about the laminar and turbulent flow. As we have seen earlier, the hydrodynamic boundary layer is a region of fluid flow near a solid surface where the flow patterns are directly influenced by the viscous drag from the surface wall. It is a formulas for a heat transfer coefficient, for a local heat transfer coefficient and average heat transfer coefficient. It is the flow regions of both laminar and turbulent flow. It is a laminar boundary layer development process. It is a formulas diagrams and formulas of flow over circular pipes. Thank you.